Welcome back to Basic Mathematics. In this video, we're going to be taking a look at fractions and mixed numbers. We've already encountered the basic idea of a fraction. We used fraction bars when we talked about the order of operations as a nice way of grouping things before performing division. In general, the fractions as a set of numbers, technically called the rational numbers, are a tool to allow us to talk about division that doesn't work out otherwise. Addition and multiplication, we've seen, work nicely in the whole numbers without any issues. Subtraction starts to get a little bit shaky. 7 minus 4 is 3, which is still a whole number. 4 minus 7 is negative 3. And that's why we introduced the signed numbers, the integers, in a previous lesson. Now we want to look at the same thing with regards to division. Sometimes division works nicely, sometimes a little bit less so. 21 divided by 3 is 7. 21 divided by 4 doesn't quite work out. And that's where fractions come in. They allow us to represent 21 divided by 4 as a number. We claim that there is a number which is the solution to that. It's just not a whole number. It is a rational number, something that was written as a fraction. So let me get my head out of the way and let's formally define that a fraction is a quotient, the result of performing division. We've seen previously, fraction notation A over B means A divided by B. And in vocabulary, the thing on the top of the fraction, A in this case, is called the numerator. And the thing on the bottom of the fraction, B in this case, is called the denominator. And looking at the numbers I talked about before, 21 divided by 4, or as a fraction, 21 over 4, we know doesn't quite work out nicely. If we set this up using a long division box, 4 goes into 21. Well, 4 times 5 is 20, which is too small. 4 times 6 is 24, which is too big. Long division, you always err on the side of the smaller value. So 4 goes into 21 5 times, and 5 times 4 is 20. When we subtract that off, we get 1. So we can say that 21 divided by 4 is 5 with remainder 1. The idea of fractions, the idea of rational numbers, is to think about the 5 as the part that you were able to divide, and think about the remainder, the 1, as the thing that still needs to be divided. It's left over and didn't get divided by 4 yet. And that's why we use the mixed number notation, 5, and then 1 divided by 4 still needs to happen. Another way of thinking about that, if we were looking at a larger number where you have to go through this long division process a couple of times, 12 goes into 300, sorry, not 378. That is going to do some weird things that I don't want to talk about just yet. 12 goes into 377. We start off, 12 goes into 37. where it will fit 3 times. 3 times 12 is 36. Subtract that off and we get 1. Drop down the next digit, this 7, and then repeat the process. 12 fits into 17 one time. 1 times 12 is 12. Subtract that off, you get 5. We call it the remainder because we don't have any more digits to drop down and keep dividing. And that's how I want you to think about this mixed number notation. When we performed the division, we got a result of 31. And then there's this other bit 5 that still needs to be divided by 12 before we can wrap up. Right, so we call these things mixed numbers, a mix of whole number and fraction in the same value. And when it comes to measuring things in the world, mixed numbers make a lot of sense. Measuring out a strip of paper that is 5 1/4 inches wide is a fairly straightforward thing to do. Measuring out a strip of paper that is 21/4 of an inch wide, a little bit weirder. So that's why in discussing things in the world, mixed numbers are what work nicely. These other guys that we started with here, what we call improper fractions, are a little bit messier in that regard. As you'll see in upcoming videos, it turns out that improper fractions are much easier to work with than mixed numbers. So while it's important to be able to finish off a problem, taking an improper fraction and writing it as a mixed number, it's also important to be able to take a mixed number and write it as an improper fraction. Before we do that specifically, I'm going to take what's going to seem like a strange tangent, but it'll come back. And I'm going to talk a little bit about measurement. You're familiar with the idea of a foot. A ruler is marked out 12 inches. And you know that you can combine measurements between feet and inches. For example, I am 6 feet 2 inches tall. If I want to try to do work using my height, the mixed units of feet and inches are very awkward and cumbersome. So generally, if I have to do something with my height, it's convenient to start off by rewriting it using just inches. But since there are 12 inches in 1 foot, I know that I can multiply a number of feet times 12 and get that 6 feet is the same thing as 72 inches. So 6 feet 2 inches is the same thing as 74 inches. All right, that's probably something that you have done in the past. And for many of you, that's probably something that you can do almost subconsciously. You don't really have to think about measurements of feet and inches. You can just perform a conversion like this. The crazy thing is that this is really converting a mixed number into an improper fraction. Saying that 1 foot is 12 inches is true. But equivalently, we can say that 1 inch is 1/12 of a foot. And so 6 feet 2 inches is the same thing as 6 2/12 of a foot. And 74 inches is the same thing as 74/12 of a foot. So exactly this process that converted feet and inches mixed number into straight inches improper fraction is the tool we're going to use moving forward to convert from mixed numbers to improper fractions in general. So what did we really do? We took the whole part of the mixed number and we multiplied I don't have enough colors here. We took the whole part and we multiplied by the denominator of the fraction. And then we took the result there and we added the numerator of the fraction. So we take the whole part, multiply by the denominator, and add it to the numerator. And notice that the denominator stays the same. That's something important to keep in mind. When you are converting between mixed numbers and improper fractions, the denominator will never change. If the denominator changes, you did something wrong. So if we have a number like 5 3/8, we took the whole part and multiplied by the denominator. Then we took that result and added the numerator. 5 3/8 is the same thing as 43/8. Looking at one more, (7 12/31). Why someone is using 31st, I have no idea, but it doesn't really matter. Nonetheless, I can take the whole part 7 times 31. All right, that's a little bit tricky, so I have to go off to the side. 31 times 7, well, 7 times 1 is 7, 7 times 3 is 21. So that's 217 plus the numerator, 12, is 229. So 7 12/31 is the same thing as 229/31. Again, when you're converting between mixed numbers and improper fractions, the denominator stays the same. We're working backwards to do division. And instead of saying we have this bit left over that we still have to divide, we're going back to try to find what number did we divide in the first place. And in the next video, we're going to really take advantage of understanding that in order to be able to perform calculations that we might not enjoy performing otherwise. I have one last thing that I want to talk about while we're still talking about the vocabulary of a fraction. And that is the idea of equivalent fractions. There are a couple of things that fall under the heading of equivalent fractions. I guess specifically the thing I'm looking at here is the idea of reducing fractions. And the reason that reducing fractions is important, if you take a few minutes and think about, should make sense. If I restrict myself to numbers where division works out nicely, certain numbers will show up many times. "24 divided by 6 is 4. 32 divided by 8 is also 4. Writing these as fractions, 24 over 6 and 32 over 8 are the same number. And that's something that will repeat. You can 28 divided by 7, 36 divided by 9, 48 divided by 12. You can keep going and find other ways of writing this fraction, which, if you perform the division, would still just give you the number 4. The odd thing is that that's also true in fractions that don't divide out evenly. For example, 1/3, if you think about that number visually, take a bar, divide it into 3 even spaces, and shade in one of them. 2 over 6. Take a bar of the same size, divide it into 6 equal spaces, and shade in 2 of them. And you've shaded in the same amount of the bar either way. So visually, when you think about it, it should make sense that 1/3 and 2/6 are the same number. And so our goal here is to find a way to demonstrate that that is the case. And the way we demonstrate that is called reducing fractions. In the first case we looked at here, 24 over 6 and 32 over 8. There are a number of things we could do with these, but the most straightforward one what if I took the numerator and the denominator of this fraction and divided both by 3? Well, 24 divided by 3 is 8, and 6 divided by 3 is 2. In the fraction 32 over 8, what if I took the numerator and denominator and divided both by 4? Well, 32 divided by 4 is 8, and 8 divided by 4 is 2. So by performing this trick of division, dividing the numerator and the denominator of a fraction by the same number, we can rewrite the fractions so that they look identical. Of course, we could keep going from here divide top and bottom of 8 over 2 by 2, and we get this fraction turning into 4 over 1. Remembering that fractions mean division, 4 over 1 is the same thing as 4 divided by 1, and dividing by 1 is really easy. So in fact, this trick will let us perform ugly division quite a bit faster if we're lucky. Consider another example of some numbers that actually do work out evenly. (192) divided by 16. You could work through and perform this division if you would like to. It works. It's a little bit annoying. As a trick of mental math, when I'm presented with something like this, I rewrite it as a fraction, 192 over 16. I recognize that the numerator and denominator are both even. And when you have even numbers, you can divide by 2. Dividing by 2 is a lot easier than dividing by 16. That gives me 96 over 8. These are still even numbers, so I can divide by 2 again. 96 divided by 2 is 48. 8 divided by 2 is 4. And we could keep going, but I do know offhand that 48 divided by 4 is 12. So 192 divided by 16 must also be 12. We can use this as a trick to evaluate division mentally without having to go through and writing out the long division process. All right, but let's come back to the numbers we were looking at a few moments ago. 1/3 and 2/6. These are numbers where the division doesn't work out. Numerator is smaller than denominator, so it's not even worth trying. But I do notice on the second fraction that I can divide the numerator and denominator by the same thing, 2 in this case, and rewrite 2/6 as 1/3. A lot of sources really stress the idea of finding the greatest common factor between the numerator and denominator so that you can reduce things all in one go. If you are able to do that, fantastic. It absolutely works and there's nothing wrong with it. If you aren't able to do that, chipping away at things piece by piece is a nice trick to help you along. And to that end, there are a couple of really nice, easy to work with divisibility rules that I strongly encourage you to memorize. These are things that are worth knowing. They come up all over the place throughout mathematics and the applied mathematical sciences. A number which ends in 2, 4, 6, 8, or 0 is divisible by 2. A number where the sum of the digits is divisible by 3 is itself divisible by 3. A number which ends in 5 or 0 is divisible by 5. I'll also mention quickly a number that ends in 0 is divisible by 10. But these three are the rules that are worth knowing offhand. because even if you don't know bigger numbers, most numbers are divisible by at least one of 2, 3, or 5. Literally half of all numbers are divisible by 2. 1 in 3 numbers is divisible by 3, and 1 in 5 numbers is divisible by 5. Occasionally, you have numbers that are not divisible by these. For example, 143 is only divisible by 11 and 13. Those are prime numbers. They cannot be divided any further. But these numbers, you have a little bit more room to work. Let me take a close look at an example of divisible by 3 because that rule is a little bit hard to understand. Consider the number 276. If we add 2 plus 7 plus 6, well, 2 plus 7 is 9, 9 plus 6 is 15. You probably know that 15 is 3 times 5, but just in case you don't, we can keep going. Adding the digits there, 1 plus 5 is 6, and you definitely should know that 6 is divisible by 3. Because this sum is divisible by 3, the number we started with is itself divisible by 3. If you divide, 3 goes into 276. Well, 3 doesn't fit into 2. 3 does fit into 27. 3 times 9 is 27. And then 3 goes into 6 twice. 2 times 3 is 6. Divide that, subtract that off. The remainder, which didn't quite fit on the screen, is 0. So very useful there. If I have something like the fraction 234 over 276. I'm sure they're both even. That's probably where I would start. But 2 plus 7 plus 6 is 15, which is divisible by 3. 2 plus 3 plus 4 is 9, which is divisible by 3. So I know that I can reduce this fraction by dividing top and bottom by 3. We already saw that 3 goes into 276 92 times. 3 goes into 234, turns out 76 times. From here, I notice that these numbers are both even. So I'll try dividing by 2. 76 divided by 2 is 38. 92 divided by 2 is 46. Still even. So I'll divide by 2 again. 38 divided by 2 is 17. 46 divided by 2 is 23. At this point, we actually do get to stop. 17 and 23 are both what are known as prime numbers. They are numbers that are only divisible by 1 or themselves. Knowing a list of prime numbers can make things a little bit convenient in being able to recognize prime numbers, gives you a quick place to stop when you're reducing fractions. But if you just keep trying 2, 3, and 5 until those run out, and then start trying some of the bigger numbers, right? Again, if you know the list of prime numbers, you try 2, 3, 5. You don't need to worry about 6, because if a number is not divisible by 2 or 3, it also won't be divisible by 6. You have to worry about 7. You don't have to worry about 8, because if a number is not divisible by 2, it won't be divisible by 8. If it's not divisible by 3, it won't be divisible by 9. If it's not divisible by 2, it won't be divisible by 10. You also have to try not 10, 11, 13, 17, 23, 29, 31. We could keep going if you would like, but that's more than you probably need. If you're looking at a fraction and one of these numbers is in the numerator or the denominator, there is nothing else you have to do except try dividing by that number. If you're looking at a fraction and you don't really remember whether it's a prime number or not, start trying dividing by the prime numbers until you get up close to that number, at which point, if you haven't hit anything, you're not going to find anything that works. All right. So there, again, just some basic vocabulary on the prime numbers and on working with fractions. Take a look at the practice problems on converting between mixed numbers and improper fractions, and the practice problems on reducing fractions. And then I'll see you in the next video where we'll start actually performing some operations, multiplication, division, and exponents on these fractions.